Good evening and welcome. My name is Dominik Schrage. I'm professor of sociology here at TU Dresden, and my job here is to present our guest Elena Esposito. It's a great pleasure to present her here in this context. Elena Esposito has been writing as a sociologist coming from system theory, on a really impressive amount of different topics. And the common ground of all these topics seems to me time. So it's temporal problems that you have been working for the last decades. And now she's working on a project, or has been working on a project on artificial communication. This is also the title of her speech this evening. And that comes from a 5-year ERC grant. And there will be a book about this topic, and it's announced for next year with MIT Press with the same title, Artificial Communication. So what you'll present here will be, I hope so, something that gives us an idea about the book that will be published soon next year. Elena Esposito is a professor of sociology at Bielefeld University and at the same time at Bologna University. Maybe later you can explain me how you do this. I find it very impressive. Okay, and besides, she has, before she worked at University Modena e Reggio Emilia for quite some years, and she studied sociology and philosophy and made the PhD with Niklas Luhmann in Bielefeld and the Habilitation as well in Bielefeld. It's impossible to name the huge number of visiting assignments, fellowships, and awards. I already mentioned the 5-year grant of the ERC for the project she will be talking now, this evening. Just a short glance on other topics. I know her book on fashion. The German title is Die Verbindlichkeit des Vorübergehenden, Paradoxien der Mode. It was a book that was for me very important when I was working on fashion and consumption. And she also worked on the time of money in financing and society, the future of futures. That's the book after the fashion book. And only 2 or 3 titles I wanted to mention here just to show that Elena Esposito is not only working on artificial intelligence, but on quite a lot of topics. And for those who have already been working with the system theory, she is the co-author of GLU, of the Luhmann Glossar, what is a very, very important and very helpful thing for students that are approaching the system theory of Niklas Luhmann. So maybe for some of you, this will also be an interesting information. Thank you very much, Elena Esposito, and we will have a discussion afterwards and after the talk, so there will be the possibility to ask questions or to get some input in the discussion. Thank you very much.
Thanks, Herr Schrage, für diese so freundliche English, sorry. Thank you for this kind introduction. Thank you for to Mr. Gross for preparing all the thing and organizing the event. It's really a pleasure to be here. Shall I try to share the screen now? So we have. Okay, it works. Can you see that? Oh, great. So wonderful. Yeah, as Mr. Schrage said, I will talk about artificial communication, and that refers to the book that will be coming now, be published now. And it was for me a big pleasure to talk about this topic in the context of this conference on artificial intelligence in the social sciences. It couldn't be the better place to discuss it. And I'm really looking forward to your feedback because I will see my talk about artificial communication is, my work on that, is an effort to think about the issues dealing with the artificial intelligence from the perspective of the social sciences. And the result, it's, you will see, probably partly controversial, so I'm really interested in the feedback from people working in the field. You, Herr Schlage, kindly mentioned that I tended to work actually without noticing it, usually with the issue connected with time. I say without noticing it because it happens to me, I think, or to several colleagues, that the coherence of what you've been doing becomes clear afterwards and not the beginning. So I pick up topics quite diverse, actually. Fashion and the finance markets, and I've been working on memory, on well, several different things, and algorithm and artificial intelligence. I worked on probability and so on, because I simply found the topic interesting. And then looking back, you find that actually there was a red thread more than I was aware of. And actually, I think it's time. And time is also, as Mr. Schlage said, the topic of the research project that we are, with my collaborators, we are developing on the question of prediction, which of course is related with time. But what I will say today is will really be focused on the topic of the conference. So we can talk in the discussion how it's connected with time, but time this time won't be the main topic, because what I really want to discuss with you is how we can understand that today, after more than 50-year discussion about artificial intelligence, the issue from a sociological perspective. So the question is, of course, are algorithm intelligent? Have they become intelligent? Is the right way to deal with the issue? Because, you know, artificial intelligence is nothing new, and the research about automatic information processing has also always been guided by the ideas that machine could, should, possibly can reproduce human intelligence. And the very label of artificial intelligence reproduces that. One tries to reproduce with machine the working of the human mind, and that has always accompanied the process of digitization of working with computer since at least the end of the 50s, when the research began. And that was, you know, work in the field. There were repeated winters and springs. Winter when the things seemed to go well, and spring when bad. Spring when they had the pressure that was going well again, and so on. So what's happening now? Because now many people speak about a sort of a reviving artificial intelligence. We are definitely in a spring. The research on artificial intelligence has a big momentum now. And actually, the advances in the field are actually impressive. When you talk now of algorithms rather than computers, I will say later something about that, about the change. But the idea is basically the same. To try to have machines that do the same thing that we do with intelligence. And actually, it seems that we are reaching now impressive results. Algorithm can do now many more things and do them much better. Also, typically the things that tradition has been a prerogative of human beings, so of beings which are intelligent. So, for example, you know, algorithm we experience every day, can answer the phone, can give information, they can carry on conversation, they can write text, and text that often cannot be distinguished by text written by human authors. They can even compose poems, as I unfortunately couldn't be present, but that's what they discussed in the part of the conference today on the techno-poetology, and that's what algorithm can do now. They can write music, they can produce images, They provide psychological counseling and many amazing things. Before discussing the question of intelligence, I would want to quickly address the issue, why now? Why are these accomplishing? What is new now in this new spring? And I think that you know, certainly work in the field, but I will quickly mention them. What happened in the last, let's say, 10, 15 years that gave this new impetus on artificial intelligence, on the accomplishment of the machines. I think that these impressive results depend on two developments that are interrelated. One is a little more traditional, one is rather new, but they both are sort of contributing to this new development. The first, of course, is the enormous advancement of machine learning. And I said that's not necessarily new, because machine learning is by itself nothing particularly new. It also had accompanied the development of computerization, digitization since the very beginning, and also with ways of success and failures and so on. But today seems to be a new moment on machine learning. Machine can learn, but algorithms seem today not only to be able to learn, but to learn by themselves, to learn autonomously, and to decide autonomously how to learn and also what to learn. You know, the technique that I discussed now, the new forms of so-called unsupervised machine learning, or the mysterious, fascinating field of so-called deep learning, where a machine can perform tasks, can learn themselves how to perform tasks that were not planned by their programmers, and the way in which the machine learns is in many cases also incomprehensible to human beings, even to the very designer that programmed the machine. Talk with machine learners, the people working on them, they also explicitly say they don't understand how the machine they program works and how the machine accomplishes the task that it's been assigned to it. So that's a huge field, and that's something really new going on. But I said two developments. There's a second development that's deeply connected with machine learning, and without which machine learning wouldn't work. And that's already hype, something, again, hype, something very much discussed, the so-called big data. So the huge amount of diverse, strange, not structured, in any case, data that are available today for machine operations. Machine learning couldn't work without big data, and if we didn't have machine learning, big data would be very, very difficult to process, in a sense. So the two things are connected. But it's not clear what big data actually are. The definition of big data is quite open, complex, controversial. You might have heard that the many V's that people are saying, velocity, variety, and so on, but it's not so clear what's meant with that. What I think is quite uncontroversial, and in my opinion, most researchers agree on, that this new kind of data is connected with the spread of the Web 2.0, or the so-called participatory web that we have not by chance since, let's say, the last 15 years. Participatory web because we participate in the web. So everybody, the user, is not just using the web, but participating in that, producing big data, because everybody produces a lot of data. Either voluntary, when we, on purpose, let's say, rate things, introduce something, upload something on the web, comment, and so on. But in many cases, also without being aware of that. With our behavior, with the navigation and choices we make on the web, with our participation in social media, but also with all the data collected by GPS, from our GPS phones, or the sensor, also called Internet of Things. All devices that produce a huge amount of strange, diverse, uncoordinated data that flow into the undefined field of so-called big data. The results of this innovation is, I think, what I quickly mentioned at the beginning, that now the machines can perform really complex tasks that up to some decades ago were required human intelligence, required the competence of human beings. So going back to our question, if now machines are able to perform these tasks autonomously, should we conclude that the machines have now become intelligent? Or are algorithms nowadays, with this new wave, with machine learning, with big data, finally fulfilling the dream or the nightmare of artificial intelligence, what people have been imagining since the 50s? That's what many people say, but that's not my opinion, and that's what I would like to discuss with you. I don't think that we are reaching machines that are becoming intelligent. On the contrary, it seems to me that this very development shows something that goes in a different direction, that the very idea of artificial intelligence is no more adequate to describe what's going on now. We need a different kind of metaphor to describe what's happening with the new algorithms. And that's connected with the way the algorithm works. Because if you look at the way this new advanced, refined, complex algorithms work, you can see that intelligence is not the point and not even the purpose of these algorithms. I say these machines can do such amazing things, the one that we usually do with intelligence, not because they finally become intelligent, but paradoxically, I would say, because they are no longer trying to be intelligent. They are doing something else. Or one might even say that the advances that we observe today, dealing with the algorithm, do not sign the triumph of the project of artificial intelligence, but in practice, I would say, the abandonment of this very project, the project to reproduce with machine human intelligence. The reason is that the process that drive algorithms are now, since relatively short, 10 years, completely different from the process of the human mind. And in fact, no human mind and no even combination of human mind would be able to reproduce them, and often, as we say, not even understand them. We cannot understand these processes because they're really different from the process of our human mind, for the human mind. And the programmers in the field say it also explicitly. They, is it working? No. They say, we do not try to copy intelligence. They say explicitly, that would be too heavy a burden and we don't need it. I make an example that I often quote in this field to explain what I have in mind. Think about the classical discuss example of a machine translation, algorithm making translation, that if you remember, the one that not so young, they have all been translators, computer translating languages, but they were really, well, everybody made jokes about them because they were sort of useful, but they were funny because the translation was quite bad and it got some words, but actually the meaning of the thing was never worked. The translation didn't really work. Now they are really excellent. I use them, deep translation, I use them basically every day because I'm lazy, and because the result is actually excellent. Finally, there are something that you would correct, but actually, machines are now becoming able to translate the text reliably from a language to another language. And what happened to produce this result now? The program clearly said that they changed completely the attitude. They stopped trying to teach the machine the languages. They stopped trying to teach a machine the rules, the grammar of different languages, and try to do now something else. the algorithm, for example, the algorithm that translates now text, let's say, from Chinese into English or from Chinese into German, doesn't know Chinese, doesn't know German. And the programmers who wrote the algorithm don't know Chinese themselves. That's not how the machine works. Using machine learning big data, now this machine, you know how it goes in the field. They don't try to find the rules, they try just to find patterns and regularities in the huge amount of text that they can access on the web. And they compare them, they use them to find these regularities and to produce text that from one engine to the other, they are intelligible and make perfect sense to the users. When we read text, for us the text makes sense. Not for the algorithm. The algorithm doesn't have to understand the text. Translating something without understanding produces a text the algorithm doesn't understand, as the algorithm doesn't understand anything of the content they process, in all cases. When they do translation, but for example, think about spell checkers, what we use every day when the machine tells us, did you type something wrong, and they correct it. The machines don't know the rules of the languages. The same algorithm can check different languages because they don't know the rules. They just look for this regularity on the web and produce these results correcting typographical errors. And the same like digital assistants like Alexa and Siri talk with us, but they don't understand the meaning of the word they say. The word simply work. Or the algorithm that write text, I quote from an author of that, don't reason like people in order to write like people. Algorithms don't reproduce the process of our mind. The machine have not learned to think like us. On the contrary, I will say, these amazing results come because they don't try to do it anymore. And that's precisely why they work so well now. I think we are facing now a way of processing data and of managing information that is basically explicitly and, well, voluntarily different from human information processing and also from human understanding. And my impression is that this difference from of the way machine works from human intelligence is not a weakness, but is the very root of the success of these technologies. I often refer to a metaphor by Hans Blumenberg, probably some of you already heard of it. He said that human beings became able to fly like birds when they gave up the effort, the idea of building machines that mimic birds and flap their wings like birds. Airplanes don't flap their wings, and that's why we can fly every day. They don't try to reproduce, to imitate birds, and then the way we can fly. I would say, for stretching the analogy a little, that's what's happening now, that digital information processing achieved the result that we see today, producing machines that act as if they were intelligent, when they abandoned the ambition, the effort to mimic, to reproduce the process of the human mind. The algorithm does something basically different. Of course, that cannot look very plausible, especially because algorithms now regularly pass a Turing test. And the Turing test has always been considered the criterion for deciding whether the machine is intelligent or not, since now 100 years. You know the test, the idea that a machine passes the test to see if it's intelligent, if it's able to communicate with a human being without the person realizing that this person is, the partner is a machine. If you don't realize that my partner is a machine, the machine has become intelligent. And that's, the test is always used and is still very much referred to. But if you think about it, it's really a very strange test. But in fact, it nowhere measures the intelligence of the machine. It doesn't refer to the intelligence of the machine. The test checks something completely different, checks the ability of the machine to act as a competent and informative communication partner. That's how the process of artificial intelligence went. What we are seeing now, there's a process of artificial intelligence called artificial intelligence that brought to build machines that didn't learn to become intelligent, but to do something else, exactly what we do with intelligence. There's a Turing test checks, the machine had learned to participate in communication, which is a different thing. That's why, rather than artificial intelligence, as the title of my talk says, I prefer to talk of artificial communications. What we are observing now is not intelligence by machine, artificial reproduction of intelligence, but rather artificial reproduction of the ability to participate in communication. And the two things are that we may claim they are different. I will say a little more about that, but of course, one could be worried that human intelligence then becomes irrelevant. And I don't think that's the case, because human intelligence is not irrelevant. It remains actually indispensable. It's absolutely required to produce this performance by the machine, even especially if the machine doesn't have to be intelligent. Because these new advanced algorithms are able to compute, combine, process data, process differences in the data that they find in the web with amazing efficiency. But they cannot produce them by their own. They find the data on the web. They find the difference, the raw material they process, they find it on the web. And these materials, the data, are participatory web, are a big part of that generated by the behavior of human beings. So we could say that through this big data, algorithms feed, in a sense, on the differences generated by individuals and their behavior, and they use it to produce new, surprising, and potentially innovative information. They need to have this raw material produced by the behavior of human being, guided by the intelligence, to produce new forms of contribution to communication. So the algorithmic process starts from the intelligence of the users that goes on the web, and that use it to process the result and to operate intelligent, to look intelligent, without, as a communication partner, with no need to be intelligent themselves. That's why, in order to participate in this kind of communication, algorithms need to access the web. That's why only now we have these amazing performances, when the web made it possible for algorithms to access all this data, all this information. This new form of, let's say, artificial communication would not be possible without the web. And actually, the breakthrough came only with the participatory web. The first example, the sort of emblematic example, is Google. Google is always mentioned as the example of the way to work with the web, which of course is before the algorithm, but sort of started using the kind of logic that produced at the end this kind of breakthrough. Because Google, someone remembers, now everybody uses Google, but some decades ago there were other competing search engines like Yahoo, AltaVista, and so on. But Google was so much more effective, successful of them, because I will say it was the first to systematically use this kind of approach that didn't try to reproduce intelligence. That's why PageRank, the basic algorithm of Google, as many people said, invented the internet as we know it today. What was the real innovation? What was the intuition behind this success? PageRank gave up completely and explicitly the idea, you know how PageRank works more or less, but the goal of understanding what the web pages say. And they explicitly relied only on the structure and dynamic of communication on the web. When we search something on Google, PageRank has to determine which are the web pages were more relevant for us, and they have to select these pages. But it does without trying to figure out what the pages are about or how they talk about the topic. They disregard it completely. They just look at how many times they've been linked by whom, linked to and by whom on the web. So the dynamic of communication. PageRank goes and sees if a page, if a page has been linked many times, according to the topic, it's considered relevant to the topic, and if the page uses the link uses a specific phrase to link to the page, the system deduces, in a sense, that this phrase accurately describes what happens on the page and takes this information into account for the following pages, the following searches. So the algorithm learns from the behavior of the user produces these links. So in a sense, the algorithm PageRank is designed to capture and reflect the choices made by user using the links that we produce moving on the web. Or as John Andrea at Google says, Google does not intend, when you make a search about Einstein, for example, Google does not intend to tell you what is important about Einstein, doesn't even care about it, doesn't know what Einstein is or who is. It just wants to tell you what humanity is looking for when it searches for Einstein, how the communication of Einstein develops on the web. And that's where Google gathers all the information, the clues that it uses to produce the search results that we get. So the intelligence of the system, the intelligence that allows Google to produce its result, remains the intelligence of the users. And the algorithm exploits it, so to say, in a sense, to direct and to organize its own behavior. So it's not only Google. Google has become a kind of example, a prototype in a sense of an approach that you can find in many other successful projects on the web. And even since like 20 years, people use the term Googleization to describe this kind of approach, the approach used on the web in an increasing number of application contexts, or models that instead of relying on experts, change their approach and feed, so to say, on the dynamics of the web to organize, to learn, to improve their behavior. This, of course, leaves a lot of questions, nevertheless, open. I will want to mention a couple in the last part of my talk, which is connected with the idea that machine learning algorithms are black boxes. Let's assume we accept this shift from intelligence to communication. What happens, what changes if we use this communication-oriented approach? What do we see? What do we don't see? What we see differently if you observe algorithm shifting the focus from intelligence to communication? Especially if the algorithm we are dealing with are, in the most case, the most advanced one, the most successful now, are, as people say, opaque algorithms, are black boxes, and transparent to the real mind, to the human mind. That's the challenge, I think, that this new approach is posing to us. If machines now work in a way that is different from our intelligence and is often incomprehensible to us, how do we control the result of their operation? If you don't try to reconstruct intelligence, rely on communication, how we can control machines that we don't even understand? And it's a big problem, because let's assume algorithms work very well, and in many cases they are really very efficient. They are black boxes, and that's not reassuring at all, especially because we don't trust these black boxes completely. In many cases, we know that the operation of the algorithm have biases, make mistakes of different kinds, or even the result they produced are wrong or are inappropriate for the context. Maybe they are right, but wrong in the context, or they are right for wrong for other reasons. You know, the topic has been discussed. I don't go into that, but probably like overfitting, algorithm blindness, and very, very diverse forms of bias that we can find in the work of algorithms: systematic bias, confirmation bias, data bias, and so on. There are reasons that make us so suspicious about the result of algorithms, and we would like to be able to verify the results of the process of the machine, that we actually don't understand. That's why we are talking about artificial intelligence, and the branch of artificial intelligence which is more relevant today, which has more development, is the so-called explainable AI. So a research that tries to address these concerns about how to deal with the intransparent algorithm by developing procedures that have the aim to explain the operation of self-learning algorithms. And they produce amazing, interesting results. But it is, if we accept this approach, it is really, again, a very difficult task, and also self-contradictory task because there's a basic obstacle to the effort to explain these machine learning algorithms. In a sense, the effort, if you try to have a procedure that makes human beings able to understand how the machine works, the process is basically hopeless. Because if you follow what they're saying up to now, it is true that the process of recent algorithms rely on the fact that they don't work like a human mind, and in a way that for human beings is impossible to understand. The machines are inherently incomprehensible. So how can you explain something which works so well because it's not comprehensible to human beings? It's not just a detail, it's the very reasons for the success of this algorithm. David Weinberg